We are nearing the end of Unit 5, and today we're looking at 5.08, Operations with Rational Expressions. The good news is there's no skill today that you're doing that you haven't done before. This is all essentially review, but you're seeing the problem in a different way. So our goals today, we're going to start by focusing on simplifying complex fractions, and then we'll simplify mixed quotients. Okay, so what is a complex fraction? Well, it's a fraction that looks like this. There are layers to it. There's levels to it. A complex fraction of rational expressions has a rational expression in the numerator, so we're talking about this, okay, and denominator. So there's also a fraction down here. So when we're talking about complex fractions, one of these fraction lines is more powerful than the others, and it's this one, okay? To simplify these expressions, we divide the rational expression in the numerator by the rational expression in the denominator. Well, you remember from a previous lesson that you can write division problems like this, right? We already knew that, but we're just being reminded of that as we deal with these very complex looking fractions. So the first step is to take this division and just rewrite it to look like this. And again, this division bar correlates with this division sign. So we have the fraction on top here, the fraction on bottom there. From here, this is just like what we did in our last lesson, right? Do you remember that rule? Well, the rule was keep. So keep the first fraction the same. Change. Remember, change means change that division sign to multiplication. And then finally, flip. So we're going to flip this fraction where the numerator and the denominator switch places. So what's essentially happening? Well, we're saying that dividing is the same as multiplying by the reciprocal. All right, so let's work out a problem now. We want to simplify this one. If you want to practice it right now, if you feel confident, pause and practice. Otherwise, stick with me. Here we go. We have our fraction on top. Remember, we are looking at this division bar as the powerful, almighty one, where we're now dividing what's on the bottom. Well, 12x minus 24 over x squared minus 3x minus 10. Now, just like we said a moment ago, we're going to keep the first fraction the same, change the sign, and flip. Do you know what to do now? Well, we need to simplify. That's the goal, right? So we need to look at each of these polynomials and ask ourselves, is there anything we can do to factor them, right? Because we want to factor to see if we can cancel anything out to simplify this as much as possible. Well, there we can clearly see two threes, right? So there's a GCF to factor out. What about this one? Well, there is nothing there to do. It's already factored as much as it could possibly be. What about this one? Well, we have a quadratic with a leading coefficient of 1. So hopefully the X method will do the trick. We're going to see that, so let's see, -5 and 2, that will give us what we need. And last but not least, this polynomial here. Again, hopefully you quickly see that 12 goes into 24 evenly. So again, we have a GCF. Now, we factored for the very specific reason of trying to cancel out, because the less we have, the more simple it is, right? X plus 2's on top and bottom, those go away. Don't forget what you already know. You know how to simplify a fraction like 3 over 12, don't you? Well, that's what we have right here, 3 over 12. 3 goes into 3 once, 12 4 times, nothing left to simplify, so we multiply across, okay? We have x plus 1 times x minus 5. Then we have 4 times x minus 2. Okay, we already canceled everything out, so there's nothing left to cancel. But what's there left to do? Well, here we have two binomials being multiplied together. So box method, here we go. And let's take that all out of the boxes. We have negative 5x plus x, and then of course the minus 5, and then the denominator here, we can distribute that. And if you're wondering, well, Mr. T, why are we multiplying? I thought we undid multiplication with factoring, and you're right. We do to cancel terms out, but once everything is canceled out, you need to look at what you have, and what we have is this. And simplifying means if anything wants to happen, it needs to happen. While here, there is multiplication that wants to be happening. So we need to do that. So there's nothing left to do. And if you're thinking domain restrictions, good job. Sometimes you'll be asked to mention them, sometimes you won't. But D could not be 2 because 4 times 2 is 8. 8 minus 8 is 0, and that would make this function, or this fraction rather, undefined. Now that we've practiced one together, you go ahead and try this one for yourself. All right, let's see how you did. The first step, which I need to include here, is just rewriting. So you're taking your first fraction. That looks a little sloppy. Let's redo it. You're taking your first fraction, and then you're just writing that division and writing your second fraction, just one step at a time. Then we do our keep, change, flip, right? That fraction is flipped around. Now we look for what we can factor. This is the only polynomial that's factorable. So we use the X method. It works out quite nicely. And then we cancel out. We have m plus 2 on top and bottom. We have a 10 and a 5 here. And you might be thinking, well, this 5 is attached to an m. You're right. But what are the factors of 5m? Well, that's 5 times m. So if you wanted to, you could write this like this, or just leave it as is. They all mean the same thing. But the bottom line is 5 goes into 5 once and 10 twice. So those need to simplify as well, giving us this. And the only thing left to do is distribute that m to both terms, and we have our answer. If you wanted to find the domain restriction here, how would you do that? Well, you would need to take this and set it equal to 0. But we're not worried about that right now. What we are wanting to focus on is a mixed quotient. Why is this mixed? Well, look at this. We do not have one fraction on top. We do not have one on bottom, right? We have mixed quotients here. We have this 1 minus, and we have two fractions down here. So for problems like this, there's going to be more work to do. And I know what you're thinking. You're like, man, I was just getting the hang of what we were doing. Now we're on to this. Why? Well, trust the process. This is not much more difficult. And it, again, is using skills you already know. So if we take a look at this, we want to ask ourselves, how can I write this as one fraction? Well, aren't we subtracting here? And how do we subtract fractions? Well, we need a common denominator, right? And if it helps you, you can rewrite 1 as 1 over 1. So how do we get these to be the same? Well, here, of course, we know 1 is a factor of anything other than 0, but we can quickly see that, well, if I multiply x minus 2 times 1, I'm going to get a common denominator, aren't I? So let's do it. We get x minus 2 over x minus 2. And then what's happening over here? Well, we have minus 1, and we have that common denominator now. So we don't need to write this as two fractions. We can now combine them, and we have x minus 3 over x minus 2. So what do we have here? Well, we basically took this mixed quotient and we rewrote it like this. New and improved and much simpler looking. Wouldn't you agree? Yeah, we like that, right? So this is a step we didn't have to do before, but we have to do it now, right? So let's do it again with the denominator. We have 1 over this plus this. And this may be a little less obvious. Remember, you can always write out your factors on the side. So factors of x plus 3, factors of x. Those are our two denominators, right? And in order to get them to be the same, we need the same exact factors. So how do we get this to look like this? Well, we need to include what's missing, right? There is a factor of x down here that we don't have up here. Okay, so how do we get this to look the same as this? Remember, order doesn't matter. We're multiplying. You can always move things around. Well, we need an x plus 3, don't we? Now these look the same. But what do we do with that? Well, we take this x, and we know we need to multiply that with x plus 3. So over here, let's do that fancy form of 1 times x over x. And the other fraction, well, we were missing the x plus 3. So that's what we need to multiply here. Fancy form of 1. And what do we get? We get x over x times x plus 3. Let's leave it factored for now, because we might need to cancel some things out. And then what do we have here? Well, we have negative 1 times x, or sorry, positive 1 times x, and then positive 1 times 3. Well, that's just x plus 3, isn't it? So this is x plus 3. So be very careful. Even though there's some distribution happening here, right? Ultimately, we are still adding, right? So we have x plus 3. Okay. Well, that gives us 2x plus 3 over this. Okay, what do? We took this fraction and we changed it. We simplified it. Actually, we didn't really simplify yet. I mean, it does look simpler, but technically we added them together. Okay, great. Now we can finally do what we wanted to do in the first place, right? We can rewrite these with our division sign, right? And remember, keep, change, flip. So let's do it. Keep, change, flip. Still leaving it factored. We're about to find out if we can cancel out. So take a look at these factors here and cancel anything out that you can. Well, we're tempted because we see 3's and 3's and 2's and 2's and x's, but actually none of these factors are the same, right? You don't see an x plus 3 on bottom. You see it here, but it's attached to a 2, right? So actually nothing here is the same. See an x here? This is attached to a -2. Can't cancel out parts of factors, right? Only entire factors. So there's nothing left to do but multiply this all together, right? So the easiest thing to do right now is just distribute that x. So we're going to get x minus 3, that's still hanging out over here, right? Times x squared plus 3x. You could put parentheses around this too if you like that. And then we're going to have x minus 2 times 2x plus 3. So we have a binomial times a binomial, and same thing here. What do we do when we have that situation? What do we do with that? Well, we need to use the box method, right? So let's use it for the top. X minus 3, x squared plus 3x. We get x cubed. Here we go, just multiplying everything together. Okay, so that's our numerator. We're going to get x cubed plus and minus. Those are going to cancel out. Minus 9x over, this is going to be our final answer here. Let's see what happens on bottom. We need to multiply this denominator. And we're running out of space, so we'll use a little box here. We have x minus 2 and 2x plus 3. Here we go. So we get 2x squared. 3 minus 4, well, that's -1. And then we have our minus 6. That is our most simplified answer. Doesn't look too simple, does it? But that is it. If you can solve this problem, you're in good shape. Again, let's review. We subtracted fractions, added fractions, so we needed those common denominators. Then we switched our division to multiplication through keep, change, flip. We tried to cancel out and we could not. So we went ahead and we used the box method to multiply everything back together. All right. So at this point, you've learned everything you need to know. We're going to go ahead now and practice some more. There will be 2 more problems, I believe. So simplify. This one is easier than the last because the denominators are more simple. Okay, hopefully you practiced and picked an answer, A, B, C, or D. Let's go ahead and work it out together now. We need common denominators. This is missing a 2. This is missing an x. In this case, those denominators are very simple, right? So we just multiply it, okay? And we have the same denominator now, right? So we can do 8 plus x. There's our first one, pretty simple, right? And then we have 1 plus 1 over x. Well, this denominator of 1 is just 1. So we know we're going to need to multiply that times x over x. So you get x times 1, well, that's just 1x or x, plus 1 over x. Not too bad yet, right? Pretty simple. Okay, let's set up what we know. We have 8 plus x over 2x divided by our second fraction. Now it's keep, change, flip. Keep, change, flip. Can we cancel anything out? Well, I'm seeing an x and an x, but that's about it. So we get 8 plus x over, multiply across, 2 times x, and then 2 times 1. Did we simplify it all the way? That seemed a little too easy, especially compared to the last one. Can we factor this more? Can we cancel anything out? The answer is no. Some of these are quicker than others. How did you do? Hopefully you're getting the hang of this. We have one more problem right now, and this is a subtraction problem. This is something you've done before. We've done it today as well, but try it out. Try it out. Just gonna reorganize a bit. Okay, let's work it out now. So we need a common denominator once again, right? So we write out what we have, and we know we're going to need to multiply. Well, this is an entire factor that's factored as much as possible, and so is this. So we can just multiply times the opposite denominator. Remember, don't multiply quite yet because we might need to actually no, we're not multiplying, so we're not going to cancel out. So we can multiply right away. So what do we have on the left? Let's see. We have x plus 3 times x plus 6. You guys should be experts at the box method by now, by the way. We do it all the time. So we have x squared plus 9x plus 18 over, let's see, what do we have? We have x plus 3, 2x minus 1. Here we go. Okay, minus, what do we have over here? Lots of box methods. 2x plus 1, 2x minus 1. Okay, we're going to get 4x squared. Those middle terms are going to cancel out, minus 1. And then what else do we have? We have x plus 3, 2x minus 1. Here we go, 2x squared. Oh, actually, we didn't even need to do that because we knew we were going to get common denominators. So that one didn't need to be done. Let's go ahead and now combine like terms. So we have x squared. And remember, this negative goes to everything, right? So maybe you want to rewrite that first. Let's do that just to avoid mistakes. We have x squared plus 9x plus 18 minus 4x squared. Negative times a negative is a positive plus 1. Okay, for the sake of time and writing, I'm just going to work on the numerator for now. So let's see, like terms. And then we have 9x by itself, 18 plus 1. And what else? Well, we just have our denominator, our common denominator. And that is it. That was a complex subtraction problem, I would say. All right. Well, that's it for today. Practice, practice. That's how you get better. See you next time.